Okay, ladies and gentlemen, we are looking at 8.5. We're going to look at trapezoids and kites. Before we do this, you might want to put this on a blank piece of paper. I'm going to do a quick little drawing for you. Okay, we've talked all about quadrilaterals. I'm just going to write quad for quadrilaterals. Quadrilaterals, what is the big definition for quadrilaterals? How many, what? Four sides. So it could be any four-sided shape. Okay. Now, from the quadrilateral, we went down to the parallelogram. Okay. We know there's 5 things about a parallelogram. Opposite sides are congruent. Opposite sides are parallel. Okay? We know opposite, so I'm going to write these down. Sides, OPP. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. What else? You guys help me out. I'm doing a lot of the talking. What else? We got 2 more. Anything else about parallelograms? Hint, hint, might be on the board somewhere. Diagonals are bisecting. I'm just going to put D-A-I-G for diagonals. If you're not answering my question, shut your mouth. Okay, one more. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Diagonals bisect. We've got parallel. Consecutive angles equal 180. Think that's spelled right? I'm going to put our supplementary. We know what that means by now. Okay. Okay. After parallelograms, what did we talk about yesterday? So we've got rhombus. And what else? Rectangle. Square. Okay. So we think of our quadrilaterals, our great-great-grandfather. Our great-grandfather. Parallelograms, the grandfather. Rhombus and rectangle are our parents, which is weird because they're also brother and sister. Yes, incestual family. And they have, yes, exactly. And they have a baby, square. I learned that in science. Okay. Rhombus has what kind of properties? Zayla, it's going to go in my pocket for the rest of the day if I see you touch it one more time. Okay. All right, so I don't want to see it again. Okay. What special properties does a rhombus have? What do we know about their sides? All 4 sides are congruent. What else do we know about a rhombus? The diagonals bisect each other, but they do that. All parallelograms do that. What is special about their diagonals? Perpendicular. Diagonals, D-A-I-G, I'm shortening to perpendicular. What else? What else? What else? Who's got yesterday's notes out in front of them? I do. So what else is about a rhombus? Look for the word rhombus. What do we see? Diagonals are perpendicular. That's for all parallelograms. Okay. I'm sorry, I'm so yelling. Oh, the diagonals bisect opposite interior angles. Diagonal, I think people have been trying to say that, and I haven't been listening. Diagonals bisect opposite interior angles. These are for rhombus. I will move this square so we can see it better. Okay, what's special about a rectangle?
All of their angles are
4 right angles. What else is special about a rectangle? Diagonals are congruent. What else? What else? Who's got 8.4?
opposite sides are congruent.
That's true for all parallelograms, right? What's especially true for rectangles? Let's see. Rectangle, 4 right angles. Rectangle, 4 right angles. Nope, that's it for rectangles. Okay. Remember, excuse me, everything that a rectangle and rhombus is, okay? Everything that a parallelogram is, a rectangle and rhombus is. So a rhombus has the 5 things for a parallelogram up here. A rhombus has the 5 things for a parallelogram, plus these new 3 things. A rectangle has the 5 things for a parallelogram, plus its 2 new things. What about a square?
A square. It is a rectangle.
It's a rectangle and a rhombus. All of the above. Is there something we know special about a quadrilateral? Interior angles equal 360. So what are the interior angles of a rhombus? What about a square? What about a rectangle? Okay. All right. So we're going to learn about the other side of the family. We've talked about the parallelogram side of the family that has a rectangle, a rhombus, and a square. Now we're going to talk about 2 other sides of the family.
The other side is sexual.
No.
Oh.
Trapezoids and kites. Okay? A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. So I'm going to draw a trapezoid. One pair of parallel sides. That's for trapezoid. Okay. A trapezoid has 2 pairs of base angles and 2 legs in what we call bases. So let's label this. This is a base. This is a base. This is a leg. This is a leg. Okay? I'm not sure why we're talking while I'm talking. Shh. Okay? Right here, these are both base angles. See? They're on the base, they're angles. All right. The mid-segment of a trapezoid is the segment that connects the midpoints of both legs. So let's draw another little mini picture for that. We've got a trapezoid, mid-segments, the middle of each leg. That's mid-segment. A kite is a quadrilateral with 2 pairs of consecutive congruent sides, but the opposite sides are not congruent. So let's draw a picture of that. A kite looks just like a kite that you'd fly outside. I'm going to draw it sideways because I've got more room that way. These 2 sides are congruent, and these 2 sides are congruent. Okay. If the legs of a trapezoid are congruent, it's called an isosceles trapezoid. So a trapezoid has a baby trapezoid that's like a weird baby has no father. Okay? And it's called an isosceles trapezoid. An isosceles trapezoid is special because its legs are congruent. Let's draw a picture of our weird little child. So we've got the base.
I thought that was a normal trapezoid.
So the bases are congruent, right? The legs, the bases are parallel, not congruent. Bases are parallel, not congruent. And the legs are congruent. See how this trapezoid looks different than this trapezoid? This is called a special trapezoid, and it's an isosceles. Why? Shh. Okay, I got a lot to get through. 8:14. If a trapezoid is an isosceles trapezoid, then each pair of base angles are congruent. So let's draw a picture of 8:14. If I've got an isosceles trapezoid, so it looks like just the picture above, I've got the parallel bases, I've got the sides are congruent, then these base angles are congruent. So 8:15 is just the opposite. If I see that the base angles are congruent on a trapezoid, then I know the legs must be congruent. So it's the converse. A trapezoid is an isosceles trapezoid if its diagonals are congruent, is 8:16. So we draw a nice isosceles trapezoid. Its diagonals are congruent. They're congruent. The mid-segment of a trapezoid is parallel to each of its bases and is 1/2 the sum of the length of the bases. Okay, let's put this in a formula form. First, I'm going to draw a little picture. So here's my trapezoid. It's any trapezoid. See how it doesn't have to be isosceles. We've got its mid-segment. This is base 1. This is base 2. Doesn't matter which one you call them, just as long as you call them something. Okay? I'm going to say that base 1 plus base 2 divided by 2 equals the mid-segment. Could I have done base 1 plus base 2 times 1/2 instead of divided by 2?
Yes.
That's the same thing, right? So if we see it that way, we're okay? All right. If a quadrilateral is a kite, then its diagonals are perpendicular. If its quadrilateral is a kite, that means when I draw the diagonals, they must be perpendicular. If the quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Exactly one pair, so again a kite. These pairs of opposite angles are congruent. Yes? That goes with the formula, yes. Base 1 plus base 2 divided by 2. And we're going to do some practice with these. Okay. We're going to show, for example 1, that ORST is a trapezoid. So let's look. What are our proofs? It doesn't say isosceles. It just says trapezoid, right? So what do we have to say is a trapezoid? What is the definition of a trapezoid at the top of your paper? One pair of parallel sides. So we have to prove that two sides are parallel. What two sides look like they're parallel up here? Tell me the letters. And OT. How do we prove that two things are parallel? Slope. Okay, so I'm going to use the slope formula today. y2 minus y1 over x2 minus x1. Where might you want this information written so you can use it on a quiz? On your vocab. Okay, so I'm going to do RS first. And I'm going to make sure I label it so I know what I'm talking about. 4 minus 3 over 2 minus 0 gives me 1 over 2, 1/2. Now I'm going to do O to T the same way. I'm going to do 2 minus 0 over 4 minus 0. 2 over 4, what does 2 over 4 reduce to? 1/2. Therefore, RS is parallel to OT. Okay, I do